Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Start with the name of Allah Almighty, who is the most beneficent and merciful. First of all, I want to say Assalamu alaikum to everyone. I hope that all of you will be fine. All of you are going very well in your life. So students, today we will discuss about the topic of function and the domain and range of function. First of all, I want to tell you that if you want to understand the concept of the function, so I want to tell you that the function is like a machine. Function is like a machine, and if we put the input values in a function, then the function gives us output values. So if you want to understand the concept of the function, then you should remember this thing in your mind, which is that function is a machine. Function is a machine. In this machine we put the input values, and this machine gives us output values. These are called output. So this is a concept of the function. So in a functions there are two terms, which is called domain and the other is called range. So there are two terms, domain and range. So all the possible values which we input the function is called the domain of the function. All the possible values which we input the function is called the domain of the function, and all the output values which get from the function is called the range. The values which we input the function, these are called the domain of the function. Those values which we get from the functions as the output is called the range. If you want to define the function's domain and range, then you can define it as a way. Function is maybe defined as the function is a machine in which we put input values to get the output values. Now we define the domain. All input values are called a domain, or you can say that all input values of the function are called a domain. And we will talk about the range, so that all output values are called a range. So these are the definitions of the domain and range. So function can be written as y which is equal to f of x. Function can be written as y which is equal to f of x. It contains two variables. One of the variable is called a y and the other variable is the x. So these are a dependent and independent variable. So in this equation, this is a equation of the functions, and this equation describes the function. So in this function there are two variables, y and x. So y is a variable which is depending upon the x. Y is a variable which is depending upon the x, and x is an independent variable. Y is a variable which is depending upon the x, and x is the independent variable. So if we put the values of the x, then we get the value of y. It means that x is the input of the function and y is the output of the function. I hope that you would have understood the concept of the functions. So now we will discuss the conditions for our functions. There are must conditions for our functions to resolve the functions problems. So there are two conditions. So first condition is that function f of x which is not equal to 1 over 0 or infinity. There are one condition, f of x which is not equal to 1 over 0 or infinity. And the second condition is that f of x which is not equal to iota or complex number. So all of you know very well about the complex number. All those numbers which confine the iota in their value is called a complex number. Like you can say that there is 2 iota, 3 iota, 4 iota, so on. These are a complex number. Those numbers which contain the iota, in their value is called a complex number. So all of you know very well about the infinity. Infinity is that when we define the natural number by 0, then this becomes infinity. Infinity means undefined. Undefined means the thing which is not exist in this world. This is called undefined. So this is not defined. This is not exist in this world. So this is the infinity. So far as the functions, this conditions must be applied so that our functions is not equal to 1 over 0 or infinity. Our function should not be equal to infinity, or function should not be equal to 1 over 0, and our function should not be equal to iota or complex number. So in this video we will discuss some important examples of the functions related, and I hope that for these examples you will understood the concept of the functions. So now we are going to solving the problems and important questions which are related to function. And one more thing about the function is that this is a graph. This is a graph. Graph means y versus the y on a y-axis and x on a x-axis. So y is a depending variable on a x and x is the independent variable. When we plot a graph between the y and f of x, then we get a straight line. This is a graph of the y which is equal to f of x. So now we are going to resolving some problems which are relating to the function concept. So first example is that f of x which is equal to 1 minus x contain square root. F of x which is equal to 1 minus x contains square root. This is a given function. In this functions we determine the values of the domain and range. So in these functions we can observe that if we put the natural numbers like a 1, 2, 3, 4, 5, we get the values. These are the axis number. These are the axis number. It means that in these functions when we put these numbers on the place of the x, then we get the values of f of x. So now we put the value of the x is 1. Then we get f of 1 which is equal to 1 minus 1 contains square root which is also equal to 0 contains square root, so the square root of the 0 will be 0. And when we put 2 in the place of the x, then we get f of 2. F of 2 which is equal to 1 minus 2 contains square root which is equal to minus 1 contains square root. So all of you know very well about the complex number. So all of you know iota which is equal to minus 1 contain square roots. Iota which is equal to minus 1 contains square roots. So now all of you very well known about the iota square. So when we take a square on both sides, then we get iota square which is equal to minus 1 square root whole square. So iota square becomes square root and square is cancelled. So the remaining part contain minus 1. So the value of the iota square will be minus 1. All of you know very well. So there are two conditions of the function is satisfied. We should remember the second condition of the function. So the second condition of the function was that f of x was not equal to iota or complex number. So all of you know that minus 1 contains square roots is equal to iota. So this is equal to iota. So the function f of 2 contain iota in their answer. So the second condition is not satisfied. So when we put the value of x as a 3, when we put the 3 in the place of the x, then we also get the complex number. And when we put the value of x as a 4, and when we put the 4 in the place of the x in this function, then we get the negative value which contain the under root, or you can say that square root, so which is also equal to complex number. So it means that from these values only we can put the 1. We cannot put 2, 3, 4 and 5 in this function. So now the domain of the functions we must be written as, and first of all I want to tell you about a real line and the open bracket or close brackets. These are close brackets. These are close brackets. Close bracket means the numbers on a real lines which exist in a solution. These are open brackets. Open bracket means the numbers on the real lines does not exist in the solution. This is the concept of the close bracket and open brackets. So now we will talk about the real line. This is a real line. At the mid of the real line is 0. At the mid of the real line is 0. So this is the right side of the real line. This is the right side of the real line, and this is the left side of the real line. So on our right sides contain all positive integers or positive numbers like positive 1, positive 2, positive 3, positive 4, up to so on as a positive infinity. And on the left side of the real line contains the negative integers or negative numbers like minus 1, minus 2, minus 3, minus 4, as so on minus infinity. So with the help of the real lines we can determine the range of this function. So we are observing that when we put these values in this function, then we know that we are eligible to put the value only 1, which is that 1. If we put the 1 in this function in the place of the x, then we get a positive value which is 0. And when we put the values which are greater than 2 or equal than 2, 2, 3, 4, 5, then we get the negative values which contain a square root on self, and their answer will be iota. So the second conditions we should remember that f of x which is not equal to complex number. So the values which are greater than 1 we cannot be put in this function. And the thing is that what I put the values which are less than 1. Yes, we put all of values which are less than 1 in this function, then the answer will be positive. So if we put these minus values, in this function, then we will get a positive answer. Like if we put minus 1 in the place of the x in this function, then we will get answer as 2 square roots. If we put minus 1 in the place of x in this function, we contain 1 minus into minus 1 square roots. So 1 is as it is, and minus multiplied with minus to get positive value 1. 1 plus 1 contains a square root, and 1 plus 1 which is equal to 2 का square roots. So this is a positive value which exists on a real line. And when we put the minus 2 in the place of the x in this function, then we get a positive value like f of minus 2, which is equal to 1 minus into minus 2 contain a square roots. So 1 as it is, when minus is multiplied with minus, then get a plus sign. So there is 2. 1 plus 2 contain a square root. 1 plus 2 becomes 3. So 3 contain a square root. So this is any positive value in a point and which exists on a real line. It means that in these functions we put all negative values and contain 0 and 1, and we cannot put those values which are greater than 1, and we can eligible to put the negative values in these functions. So the range of the function becomes zero. You put the close bracket on a 0. It means that the 0 exists in the solution, and minus infinity. This is a domain of the function. So the domain of the function becomes close bracket 0 to minus infinity. These close brackets are expressing that these values are exist in a solution. So now we want to find the range of the function. So this is the other method. You can write here for range, as we know that y which is equal to f of x and f of x which is equal to 1 minus x contains square root. Then we put the value of f of x in this equation. So y becomes 1 minus x contains square root. Then this process is going to determine the range of the function. So now we check the values 1, 2, 3, 4, 5, 6 in the place of the x in this function. So when we put the 1 in the place of the x, then we get a value 0 which exists on a real line. When we put the value 2 in this function, then we get the negative value which contains a square root on itself, and whose answer will be equal to iota or complex number. So this is a second condition of the function, is that the f of x which is not equal to iota or complex number. We cannot put the values which are greater than 1 in this function. We cannot put these values, but we can put the values which are less than 1 in these functions, as the same as when we find the domain of the function. So the domain of the function becomes, this is a real line. At the mid of the real line, 0 exists, and on the right side all the positive numbers are positive integers. On the left side all the negative numbers are negative integers. So what will be the range of the function? The range of the function will become, you put the close bracket on a 0 and you put the close bracket on a minus infinity. So this is the range of the function. So domain and range of the functions is same. It is because f of x which is equal to 1 minus x contains a square root, and when we put the value of f of x in this equation, so y becomes 1 minus x square root. These and these both equations are same answers. The answer of f of x, which is equal to 1 minus x, and the answer of the y, which is equal to 1 minus x square contains square root. These are same. So when these are same, then the domain and range of the function will be same. So the range of the function will become close bracket 0 to minus infinity. This is the domain of the function and this is the range of the function.